Okay, so let's talk about the extra credit stuff, and then let's talk about the exam on Thursday, and then we'll keep looking at the stuff we've been looking at. So if you look at, let's see. Oh, first I was giving a pitch out for Grace on here. They sent out a I don't know, questionnaire type thing to get a feel for what everybody kind of thought they'd get the most out of if Grace started doing those kind of things at their events, as well as best meeting times, I believe is in there. And if you fill it out, you get a chance of winning a gift card, whatever. But, I think both men and women should take advantage of Grace. We don't have a ACM chapter, a generalistic one. So Grace is our ACM chapter, and there's nothing wrong with that. So we should all be taking part in this type of thing, because it's really, ACM is really an international group. It's an American group, but there's international groups of ACM at universities across the world, and the things that we can do allow us to maybe interact with some other universities, and you can also get some stuff out of it that you're maybe not getting in the classroom. So I encourage you to participate in that survey thing and try to get involved in Grace in one way or another. Then coming up here to the extra credit. So what I gave you is I gave you the whole schedule here for tomorrow. So I'm giving you 3 different extra credit opportunities. You can attend the keynote, and then in the afternoon there's 2 different, talks. 2 different talk sessions, and within each session there's 3 or 4 different talks you can go to. So what I'm giving you is kind of like this token thing you can use. You can get up to 3 tokens, per class you're in of mine. So a token can be used to replace a quiz, a homework assignment, or give you 5% on an exam. Even if you don't perceive you need the tokens, I'd still encourage you to go to this thing. A lot of people worked pretty hard putting this together. I was talking to Dr. Locklear yesterday, wondering how often do they, this is the 500-year Reformation celebration thingy, I guess. But how often is it correct? You don't celebrate it every year. So it gets too old, right? Do you do it every 50 years? Every 100 years? I asked him what it was like the last time they had it 500 years ago, and he said it was like a Tuesday. He was under the weather. It was okay. So there is a breakfast thing. I don't know what's going to be at that, but if you want free breakfast, 8:30 a.m., I'll be here for that. I never pass up a free meal. And then I encourage you to go to chapel if you are around. Dr. Ferry usually gives pretty good chapel services. Keynote thing, which is in the chapel, starts at 10:30. I recognize his name. I don't know who he is. Anybody know who he is? But in any case, he's giving a talk. And I don't know, it's probably something at least reasonable. And the punchline is, for the extra credit, I said you had to give me a 1-page written dealio for each thing you go to and how it connects to computer science. That one should be fairly easy to make a connection, because he's talking about vocation in general, so you'll be able to twist it to your own vocation. The other ones down here might be a little bit more hit and miss. Noon is lunch. I assume that better be free. If it's not, I'm sneaking in. This is supposed to be all inclusive. It's a celebration. Let's see, 1:30 panel discussion, blah, blah, blah. I bet you that one's gonna suck. Still go to it. officially, but I might not go to that one. Then in the afternoon is when the other opportunity starts. So 2:45, and then the second one is, what's it, probably 3:45 or something? 4 o'clock. So let's see, what are the possible topics for these guys? So in Terrace Room, from Martin to Motherboards, Technological Artistry in the Wake of the Reformation. So Dr. Locklear is giving that one, and my understanding is he doesn't have it written yet. So I'm his fill-in for some event this afternoon because of that. You see, Martin Luther did not invent the cell phone, but the Reformation did liberate creative minds to rediscover the joy of creative learning. Creation. Learn how that spark resulted in scientific discovery and technological innovation. You may be surprised, or whatever. So obviously that one would be pretty easy to connect to computer science, but I'm not necessarily pushing that one. If it interests you, go to that one. Let's see. Business and Vocation, having Jesus as your customer, Brad Condy. That sounds actually like it could be relatively interesting. Dr. Condy is in the marketing department. So Christian business people are more than mere professionals. They follow a vocation by which they serve God. By serving their fellow humans, as Luther and the Reformation emphasize. One way to approach the vocation of service is to act in business as if Jesus is your customer. Batterman School of Business faculty will present ways in which the Lutheran concept of vocation service to God and other people is integrated into business courses. That could be actually kind of interesting. I don't know what, I mean, like, how can Jesus be your customer? Like, would you actually charge Jesus? I mean, or he'd be like one of those, like, you know, like my dad was a dentist, and like when other doctors and stuff came and saw him, they, you know, there was like a trade-off, like, you know, we got to see the chiropractor for free, chiropractor saw the dentist for free, and it was like a thing. I mean, do you charge Jesus? So now all of a sudden you're not charging any customers. So now you're living like a pauper. Okay, you're homeless. Okay, and that might be an interesting one to see the direction they go with that one. Let's see. Reformation and Jeopardy. Brad Alice, I actually heard him speak. I mentioned at the beginning of the semester, I think. I talked about our faculty retreat. They were talking about the different dynamics that are coming out of high schools today, feeding into universities. Something like less than 25% of students coming out of high school today are prepared for college. There's just like this change. And lately we've been discussing in the department kind of what's causing this. I think a big thing is, you know, I think high schools are doing less good of a job, but I don't think it's that the high schools suck so much as it is that I think real life is starting a lot sooner for young people today. You know, they're coming into college with car payments and credit card debt and all these other things where years ago those weren't things. You didn't have credit cards, so there was no debt. You just were broke is what you were. So yeah, I think there's all sorts of interesting dynamics that are changing there. So the seminar would begin with a short overview of Luther's life and work, along with the direct impact of the Lutheran Reformation on education. Using the game of Jeopardy, the seminar has been specifically designed for those who may not be familiar with the Reformation and are seeking an interactive seminar experience. Okay, so it looks like he's going to be teaching about the Reformation in a game type setting. I would be very surprised if he doesn't somehow swing in something about young people today. That seems to be his research area, trying to understand millennials, and then what is it, Generation Y? Or are we in Generation Z now? Okay, yeah. So we had Generation Y, then we had millennials.
Generation X, and then millennials are technically Generation Y, but nobody calls them that.
Oh, okay, I got you. So you had Generation X, then you have millennials or Generation Y, and now we have Generation Z. And there, Generation Z, that's is that what, anybody born after 1990? I think it was something like that. No, born after 2000.
Yeah, it depends exactly where you look. Somewhere between like 98 and 2000.
Yeah, okay. So anybody in here born in 2000 or after? Or late 90s, 98, 99? Well, how old would that put you? 18, 19? It's kind of freshman. We're right in that transition. Those are the ones that are coming in 25%, not only 25% of them are ready. So that should make things interesting, I guess. Let's see. Health professions. Think of vocation as worship. You will be challenged to answer several questions. Why might vocation be a form of worship to God? Where did the concept of vocation begin? How did the Reformation revive the concept? What is the difference between vocation and career? That could be actually an interesting talk. How can you prevent the vocations God has given you from becoming careers or just jobs? How through vocation can you represent the image of God to his world? I don't find that all that interesting, but it's another option. Let's see, we have a nursing one. Is this all under the same? No, these are different locations. We have a nursing and a pharmacy one. Nursing, the church, with its emphasis upon Christian charity and good works, played an important role in providing health care, encouraging care of the sick and the poor, and setting ethical foundations for medical practice in medieval Europe. Was there medical practice in medieval Europe? An eclectic mix of healthcare providers persisted in Europe until well into the 18th century. The Reformation had a significant impact on healthcare in terms of education and practice, paving the way for the establishment of charitable institutions. The development of a new vision of health and healthcare providers culminated in the formation of new organizations dedicated to caring for the sick and the birth of modern nursing with Florence Nightingale. I guess that could be interesting enough. I think the part that interests me in there maybe is just thinking about the evolution of healthcare. I've seen in like movies and stuff, and they used to just like, oh, something's wrong with your arm, let's just cut it off, or something like that. And I think they used a lot of leeches for things. Let's see. Then lastly, pharmacy. Luther had an intriguing spiritual history from law student to monk to reformer. Discover the data supporting the impact that spirituality makes on patient health outcomes. Well, that actually could be kind of cool. Learn how pharmacists use a patient's spirituality for therapeutic benefits and how to take a spiritual history to find out what their background is. Finally, you have an opportunity to participate in a simulated patient spiritual history taking exercise. That actually could be somewhat interesting from the perspective of, if you pull it out of healthcare, you might be able to think about how does your own spirituality kind of affect your vocation? How does it, affect you as computer science folk? But also at the same time, this exercise of taking a spiritual history might help you in talking to other people. Like how do you ask a question without like asking the question? It's like, hey, you, what are your thoughts on Jesus? So tell me. All right. So you can go to up to 2 of those. There's 2 different sessions and they just repeat each other. So I'd encourage you to pick 2 of those and go to one during the first session and one during the second session, or go to as much of that as you can. All right. Questions about the extra credit DLE flippy thingy? How many of you are planning on going to something with Reformation Day tomorrow? Okay, most of you? All right, good. I'm going to at least hit the meals. I'll be there for the keynote, and I'll be there for at least one of the talks in the afternoon. Probably both, but at least one. Okay, now let's talk exam. Exam will be in class on Thursday. So it'll be designed to take, you'll have the whole class period to take it. I'll probably design the exam to be about a 50-minute exam. So, if you I don't want it to be a time pressure thing. This exam is probably going to be somewhat different than our final. Our final in here is likely going to be down in the lab doing something live. And there might be a written portion of the final as well, but for right now, I think this is going to be more about some of the nuts and bolts that we've been talking about. So a couple of things to expect. I'm going to go ahead and open up one of our scripts here. Do I have to close it? That's weird. Let's just go into baby movement here. We'll use this to talk about some stuff. So I'll be asking you some questions about scripting in general. Well, so there'll be kind of two parts to this. I guess 3 parts. So we'll talk about game programming in general. Oh, you only get a 30-day trial for evaluation purposes? How do I update? I thought Visual Studio Community is free. Weird. I'll just push that over to the side for right now. At least we can be able to scroll through this some. Well, that's unnerving. All right, so then let's do this for right now. We do have a site license through the department, so we'll be able to. Everybody will be able to get keys. This is more of an inconvenience at this exact moment than that's the wrong. Where's my properties? Or was it in, maybe was it in build settings and then player settings? Where's my choice for, we did this at the beginning of the semester, choosing your IDE. Thought it was under something called project settings. At least it is on the Mac.
It's under something called project.
Yeah, because here the default is.
Well, let me find preferences up.
Well, let's look at this then. It's probably in there somewhere. Let's look at getting the key. Okay. Or can I enter in a new code? Please make sure your internet is connected. Check for an updated license. I am connected. Well, this is unfortunate. All right. Well, then let's just force, I think we just right click on a script and tell it to open in mono.
You just have to re-enter your credentials.
Well, I don't think so.
That's what I had to do.
So under this guy up here,
No,
I'll re-enter your credentials. So now it's just okay with it? That's weird. But why did it say 30-day trial at first? So maybe it's a 30-day trial if you're not logged in. Otherwise, as long as you have an account, you're legit. All right, whatever. All right, so let's talk from a scripting perspective first. And then also I want to go ahead and pop something else open here. Oh, 549131. Trust. So this will let us bring up the presentation from earlier in the semester. Okay, so some of the early things we talked about, there could be a question like, what is a game engine, specifically talking about implementation of physics. Kind of, it's an IDE for writing video games where it's already implemented physics. It has the ability to do drag and drop stuff, things like that. I probably wouldn't ask you a question so direct as what is a game engine. I might ask you to maybe list 3 things that a game engine does for you or something along those lines. Certainly there'll be a question dealing with frame rate. We had a pretty good discussion about that, kind of what our goal is and what are the things that impact that. So frame rate is how many frames appear on the screen at, per second, and that ends up being kind of user experience. I guess there could be a question dealing with monitors specifically or what your eyes are capable of, but realistically, I think the more general concept of frame rate as it relates to user experience is the more important concept there, and kind of what does the GPU do related to that. And that can kind of connect into the scripting side of things, which we'll talk about here in a few minutes, which kind of gets into, your GPU is going to be able to push so many frames per second under ideal conditions. Now, what are the things that can impact that? If you have a zillion game objects that are all calling updates and doing a whole bunch of crap inside the updates, these are things that are going to hurt frame rate because now you're doing too much stuff in between frames, and frames are going to have to be skipped in order to finally catch up and that kind of stuff. So understand the concept of frame rate and how a better frame rate is actually better for us than a lower frame rate, but also maybe understand some of the limitations where perceived frame rate is going to be limited by our monitor as well as our eyes. But even within the eyes discussion, then you have the situation where if your eyes can see 45 frames per second and you're driving a consistent 60 frames a second, could a human tell the difference between 60 and 120 frames a second? The short answer is probably. There's just almost a perception of smoothness type thing that happens in there. So, but I probably wouldn't get too much into that, other than maybe ask a question. If we were looking at GPUs, what's the advantage of getting a GPU that can, let's call it a super expensive GPU that can, under benign conditions in your game, it can push 190 frames a second when your eyes can only see 45 frames a second. What's the purpose of getting that overpowered super horsepower GPU? Just so you can brag more to your neighbors? What do you think? What is the purpose of that? Go ahead.
Or when there's a lot of things scrolling it down, it doesn't drop below. So.
Yeah, so it's for the worst case scenario. Right, so fine, you're getting 190 frames a second. Majority of the time, who cares? When 60 would have been fine, but it's when you walk into that town that has a zillion things going on, and under a normal GPU that you were kind of able to keep the 60 frames a second, it drops down to 8 frames a second. Under your $1,000 GPU, it drops down to 94 frames a second or something like that. So cuts in half, but it's still better than you could have than you can see. Also, this concept of DPI, I probably would not ask a question about that. It would be pretty low on my priority list. That's kind of a new level, and it's not something that directly relates to gaming as much as we were just kind of talking about screens. So there's kind of two different levels of perception that humans have. One is how many frames per second we can see. There's more than two, but let's just say the two in this example. Number of frames that we can see, and then there's what's each frame made up of. So now we get into like resolution and stuff like that. These are things that drive frame rate. So the more pixels that are on the screen at a time, the harder it is to display that single frame. All right. Well, then even within that, we have this dots per inch or pixels per inch scenario where you can have two screens that are the same physical size, and one screen might be capable of 1920 by 1080 resolution, and another one might be capable of, let's go on some extreme thing, let's say 640 by 480, so some standard definition. That'd be a pretty old monitor if it was only capable of 640 by 480. But in any case, same physical size screen, but one can only show 640 by 480. The other one can show 1920 by 1080 number of pixels. So way more pixels on this screen than this screen, even though physically the screens are the same size. That means more pixels are squeezed into a smaller space, or more pixels are squeezed into the same space over on this monitor, giving you a higher DPI. Does that make sense? Well, once DPI gets so close, you get so much clustering, now the human eye can no longer see the pixels. And we would call that good, right? If you have a high resolution screen and you're able to show enough frames per second, and you can't actually see individual pixels, now it's like just a clear image to you. It's reality. Because if you walk around, you don't see pixels on people, right? Or pixels in the wall. If you start seeing your real life pixelated, then now we need to talk, because now we start getting into that. Are we living in a simulation? There's books about that. They're good books. But in any case, I care more about frame rate than I care about DPI. I think frame rate is the better thing. I wonder how long that snoozes for. All right. So comparing the couple of game engines, fair game question, but I probably won't go too much into this. Obviously, we've picked Unity. In fact, I would say that I won't ask a question about Unreal Engine. We haven't talked about it at all, and it's not really worth it. So I guess understand that we're using Unity. All right, so now we start getting into the scripting sides of things. So as far as the exam goes, we kind of have three different pieces from the semester so far. We have kind of the background information on what is game programming and what are some of the driving forces of it. Then we have the tool itself, Unity, and we'll talk in a few minutes about some of the different game object stuff that we need to be comfortable with and understand what they are and that kind of stuff. And then we have the scripting sides of things and what those different things mean. So we should understand, I probably won't ask anything about late update. It's not a hard concept, but certainly these three functions, start update and fixed update, you should have a clear understanding of what those guys are for. Start gets called once, update gets called once per frame, fixed update gets called often to maintain a to emulate a 60 frames per second cadence. Okay, so update and fixed update, these are our opportunities to have logic that updates your game very often. You should understand our position primitives, vector 2s and vector 3s. We've primarily used vector 2s in here because our vector 3 or z is always the same, right? We don't have a depth in 2D stuff. But understand those primitives that we have used up to this point. Now, beyond that, let's go ahead and add a slide for Unity elements. All right, so we should certainly understand what sprites are. Okay, we should, that's kind of our default game object for showing stuff. We should understand the concept of animations. And through animations, we have like our animation controller. So what's the purpose of an animation controller? Understand that. Maybe even within that, the idea of triggers. So we come back into this guy here, and I go into my animations, and we'll just go into one of our animation controllers. We have these things called triggers in here. So these triggers, how do you use them for determining which state you want to transition to? So those triggers are used in relation to these transitions. The idea of tiling, probably won't ask too much about that. Things I care more about, I suppose, are going to be colliders. Rigid bodies. Prefabs. Concept of a ragdoll. So what's a ragdoll again?
Kind of a copy of your main object that you can tell off or do stuff with and not affect your main object. Okay,
so kind of a placeholder, right? That we can show, like we're using it on our guy's death. Right, so we just kind of have this like fake ragdoll that gets thrown up in the air and looks like our dude is dying, but realistically what we did is we just had our dude disappear for a moment while the ragdoll took over. How do I get these things to stop popping up? I keep feeling like I turn off the notification thing for YouTube and it just keeps coming back. What about prefabs? What are those? And why would we want them? Go ahead.
A set of game objects that are linked together that you can reuse them over and over again. It's
So
constantly having to remake it. put in scripts and stuff.
Yeah, we kind of write them once. So we used it for like our enemy going back and forth thing where we kind of packaged in a couple of like little fencing pieces. So we drag the prefab out there, drag our fencing pieces where we want them, and then our dude goes back and forth between those pieces. And now we're able to kind of throw an enemy anywhere we want in the scene. And because we've already written the logic for that, we can pretty quickly populate our scene with that kind of stuff. Make sense? Similarly, we've done that with our container for our power-ups. Okay, rigid bodies, colliders. So those are the things that are helping us, detect when two things interact with each other. Now, within these, if we go to colliders, what's a trigger as it relates to a collider? That would be a fair question. Then when you start getting over to some of the scripting questions related to colliders, so under trigger, we would have something like on trigger enter. Under colliders in general, we have on collision enter. I think it's what collision 2D enter, but whatever. Or on collision enter 2D. What's the difference between those two? On trigger enter and on collision enter. I think it's on collision enter. Let me make sure I'm giving you the right. Yeah, on collision enter. So what would be the difference between on trigger enter and on collision enter? Go ahead.
On collision enter checks every time it hits anything. On trigger doesn't necessarily collide with stuff, I think.
Okay, so on collision enter will get called every single time a rigid body with a box collider collides with anything else, right? It gets called every single time. Now, when you make a collider a trigger, you're saying take off general physics. So now instead you're saying treat this guy as a trigger. So now it will no longer call on collision enter. As an alternative, it'll call on trigger enter. So on trigger enter allows you to deal with that collision, that trigger-based collision, but you know that real physics hasn't occurred. Real physics does not occur with a trigger. Real physics would occur with a typical collision. All right, so these guys are used under different circumstances. So for instance, if we want real physics, we want something to bump into something else and actually have it do its thing, right? Have it act like what physics would look like. But we also want to react to it programmatically. We would use on collision enter. If we want to know when something occurs, but we don't necessarily want real physics to occur, we can use a trigger, or we can just turn off the rigid body for the guy, then real physics won't happen anymore. Make sense? All right, so these guys are pretty similar to each other. I don't know if I would ask a direct question like, what's the difference between them? I might give you, so as an example, it could be like a scenario and ask you how you would solve this. And you might have to give me like a paragraph describing how you might go about solving this. Like I would put, if I had two players that were supposed to interact with each other, I would put such and such on this guy and such on this guy. And then I would have this guy's script look for a collision where the tag on this guy. So we might talk about tags. Matches a certain thing. So you can react to that related to one of your guys. All right, so I would actually expect there to be at least one, if not two, different kind of scenario-based questions where you're going to show me that you can kind of think through a solution where there isn't necessarily a right. Well, there might be many right answers or any reasonable answers. Like you might give me a solution that, yeah, that would probably work. I mean, that's funky, but it would probably work, and that's reasonable. Because, that's kind of what we're doing with game programming in general. It's all this kind of this smoke and mirrors, right? We're coming up with ways of tricking the end user into thinking that things are happening the way we are advertising that they're happening, whether we're faking it or not, behind the scenes. So, what I want to see you do in a question like that is I want to see your process of thinking through it. So don't get too caught up on what is he looking for the right answer. I'm looking for how do you take these tools that are sitting in your toolbox in front of you and put them together in some sort of way that gives you a solution that's in the ballpark of a reasonable solution. Okay. And that would be worth full credit as opposed to you talking about things that are completely unrelated. So don't try to hunt for the answer you think I'm fishing for. Instead, give me your approach to it. Because we've already seen in class, my approach isn't always the best approach. It's just I've decided here's the tools that are in front of me, and I'm going to put these together in some way. And sometimes our guy slides more than we want him to slide, and sure, we can sit there and mess with it for 2 or 3 hours and probably get him acting the way we want him to act. But that's what we came up with. If we did it again, we come up with a little bit different solution, but that's okay. That kind of comes down to our creativity and how we work through this. It also kind of leads us down these lines of this idea of best practices for different approaches. So, if you have 50 people who've all implemented some concept, some game mechanic, and at some point we've come up with this best practices idea, like, out of those 50 approaches, this is the one that pretty much works the best. Or most people think this one gives you the best, the best look. A lot of times those things then get drug into the Unity tool. So, for instance, in the second game programming class, when we start dealing with 3D pathing, making a guy go from here to here and skip all these things in a row. Now we're talking about kind of artificial intelligence-ish type stuff where you want the enemy to not just like pass through walls and stuff like that. We want him to walk around things. Well, built into Unity is a tool for mimicking that in a best practices type way. Now, a lot of people you read out. So if you're making kind of let's just call it a generic type game, that might be perfectly reasonable for you. But if you're writing a game that has a whole lot of stuff going on in it and performance is really, really, really important, you might decide that the built-in thing is more of a generic solution than an optimized solution. You might not go with that. Unity decided, for most common cases, this works the best and it's easy to implement. And the trade-off between performance hit and experience is reasonable. And that's why they've included it in there. And then you read forums and they say, I would never use this. This is the worst thing since, taking vows of not eating. What's that called? Hunger strikes? I would never take a hunger strike. I would only last like a year or two. You need water, right? Like, I wonder how long can like a big person live without food? Like, is it actually longer, or does your body like become less good at just living off its own stores?
Very should be able to.
Yeah, it's like a bear, right? You go into hibernation.
Right.
Yeah, see, that's why.
As long as you're not out in like rough environments where you have to have physical strength, which, depending on some people who are bigger, don't always have muscle.
Oh, I see.
So in that
they're
case,
soft. Yeah.
Right, in that case, it can be harder. If it's in a rough environment, it can be harder. But that wouldn't necessarily be
because you're expending more energy just moving around.
Right.
Yeah.
But if you were just like hibernating like a bear, then
That makes a lot of sense. So who makes out best on like those plane crashes where they have to decide how quickly to turn to cannibalism? Saw some I think it was on College Humor or something like that several years ago, where there was like these people got stuck in an elevator. And like it was like, how quickly do you turn? I mean, they were in there for like 9 minutes or something like that before people had already set up like clans. I think it was like almost a Survivor type spinoff where there were alliances and they were deciding who they would eat first. I mean, they weren't even late to work yet. It had been going on such a small amount of time. That's pretty funny. All right. We're going over. So obviously, anything that's in class is fair game. So cannibalism is now fair game on the exam. Well, we also have zombie babies, so that's So, all these things and how they relate together and how you can use those tools to solve problems will be kind of fair game on the exam. So I would expect at least one question like that, probably even two, where I want you to think through a problem. They would probably be different kinds of problems, asking you to solve something. And it might even be something that we haven't necessarily, it probably would be something we haven't done in class, but not necessarily a far-fetched scenario, just some scenario that's in the ballpark of things like we've done, but something new. And having you just kind of explain, well, based on what I know, this is probably how I would try to approach it, and just kind of see what you come up with on that. Other types of questions, I might show you some scripts. It probably wouldn't be tons and tons of code, but a script that is somewhat self-contained. Maybe it has a couple of variables at the top. It has a small start function, and then maybe an update. And I might ask you, if this script were attached to a game object, what would be the behavior of that game object? Ask you to be able to read code. There would probably be one or two questions where you will have to write a couple of snippets of code. I wouldn't ask you to write something huge. But for example, it would be fair game for me to write the code to make a specific game object invisible, for example. So you would have to get the render component and disable it, for example. So you've shown me that you can get the game object that owns the script, ask for his component, that is the sprite renderer, and then tell that sprite renderer to disable itself, so it's no longer showing stuff on the screen. So kind of like through 2 or 3 lines of code. You could do it in 1 line of code, I guess, if you want, that type of thing. And I probably wouldn't be looking for absolute 100% perfection. So I don't want you to spend too much time, memorizing, like the exact capitalizations of sprite renderer and stuff. Get it in the right ballpark, and that's going to be fine. But don't just make something up. Don't write it just in English. But actually, writing in English would be better than leaving it blank. So, if you basically say, yeah, well, the first thing I need to do is get the sprite renderer component. Don't remember how to do that, but do that. And then turn the guy off. That would be worth, a reasonable number of points, because at least you kind of knew the process. You just didn't remember the syntax. So I'll probably have you read some code. I'll have you write a little code, but this will be primarily a reading code explaining the process of solving a problem, and probably a fairly minimal amount of actually writing code on your own to solve a problem. It would be something small. Expect on the final exam, though, it would be much more of a real-time project type thing where you create something where you'll have to write the code and that kind of stuff. So, we'll be down there for like 2 hours. You'll have some sort of small game you put together in those 2 hours, something like that. All right. Questions about the exam? Anything that you are afraid might be on there that I didn't discuss? Certainly the concept of a public variable. Why would we choose a public variable? To kind of expose that to Unity if you want something you can change on that side. I'm not sure how I'd ask that question, but you should certainly be comfortable with it. Maybe it would come in the form of the script that I show you. Here's a script that does some stuff, and you look at it, you notice there's a public variable for speed or something like that up there, and you might mention that, the whatever game object you attach this to in his inspector, you would set the speed in Unity for that, and that would pass into the script. Something along those lines. All right. Anything else? Okay. So, having said that, then, and that'll be this Thursday, right? Today's Tuesday. Yeah, this Thursday. And I plan on having those graded pretty quickly. I don't know what day I have to have midterm grades in by, but I plan on probably having midterms in on Friday. So the grades will be up on Blackboard by the end of day on Friday, definitely. Okay. So let's see where we left off here. Oh, that's right. We left it off at toggling between different kinds of power-ups, right? So we had our power-up that involved the guy, the make you bigger guy, and then we had another power-up. We haven't actually given the second ability for the other power-up, right? We just kind of talked about, like in Mario, you have like the power-up that makes you larger, and then we have the power-up that gives you like the ability to throw fireballs and that kind of stuff. And so, and then somebody mentioned, I think, that there seemed to be, I think we were debating whether or not Tiny Mario could shoot fireballs in the original Super Mario Brothers. He definitely could in a later one, but I think we kind of landed on the idea that in the original Super Mario Brothers, the first power-up you would get would be the mushroom that made you bigger, and then if you were already larger and you hit a thing that would have the next power-up, it would give you a little fire flower thing that gave you the ability to throw stuff. So we were looking at what it was going to take to toggle back and forth between those two. So what we had in here is our prefab. We have our power-up container here. So our power-up container, we put in there, we have our firegrass, and we also put a rock. So the rock and the firegrass are our visuals for our two different types of power-ups. And by default, we want to have one of these guys show up. So I think if I click on Power-Up Container, this is where we have our Power-Up Container script. And we have, now this could probably be the issue. Why is rock showing up differently than our firegrass? So this rock, so this guy is a sprite renderer with firegrass. This guy is a sprite renderer. We need to give him a rigid body and a box collider so he does the things that we want him to do. He needs to be able to interact with the world around him. I'm not sure if that's why he's not showing up right now. So let's go to our rock. Let's give him our rigid body. We'll give him our box collider 2D as well. We'll give him rigid body 2D. We'll turn the box collider off by default. Do we make the other guy a trigger? No, he's not. He's just a normal box collider. So we do it on collision enter. Okay, we used auto mass for our rigid body. And then we also froze the rotation on Z. That way, when the rock falls off of the end of the thing, it doesn't do like a weird twisting, turning thing. So having said that, that would be another fair game question for the exam, dealing with what's the purpose of freezing rotation or freezing positions on a rigid body? Something like that. When might you use something like that? So that would be this kind of example where if you let normal physics take over, when that power up goes off the ledge, it would, tip, it would fall like we would expect something that you pushed off to fall, where we probably want our power ups to just stay upright. So we lock its rotation. So we've turned off an aspect of physics rather than all physics. All right, I'm going to turn the sprite renderer on real quick for our rock and make sure that guy can show up the way we want him to show up. Okay, and he can. He looks all right. And then let's go into our, if I go to my Powerup container, I'm going to reset the rock in there. I wonder, why does that rock look different? It's like different icons. Let's go into our code for our Powerup container. Game object, rock, firegrass. Okay. It looked the same there. It's very interesting. So even up here, this guy is a blue guy. And this guy is multicolor. What's the difference?
I think it has to do with the one's part of the prefab and the other's not, because if you click on it.
Oh. Yeah, thank you. There we go. Yeah, so I came up here and I clicked on apply because I made a change to my prefab here. And when I apply it, what that does is it makes all other prefabs follow those same rules because we're adding to this guy. So actually, I don't think that was something that was breaking our logic, but in this particular one, but certainly the reason why they were different colors. All right, so let's look at when we hit that, why the rock is not showing up. So that's going to be in our code here for Powerup container. So right now, when we say show Powerup, which I believe should be getting called, let's just do a print here, inside here. Okay. Let's make sure this guy is getting called to begin with. Okay. A little bit of a gravity issue. but it is showing up. Like, come on, zombie baby, you got to catch that. This is the super Powerup. This is not supposed to be easy to catch. So let's look at normal firegrass. We did use auto mass on that.
Increase the gravity scale.
So we had gravity scale at 30. And for our rock, so right now the Powerups do the exact same thing as the other. Man, that baby is just terrifying. All right, so we want to have our Powerups do a couple of different things though, right? We want to have our initial Powerup do the thing where the baby gets larger, but we want to have that rock-based Powerup to give us some other power. Right. So maybe the power is, did we decide we'll be able to throw something, some kind of attack? We couldn't decide what we were going to throw. Maybe the baby can throw rocks. Suppose we want to keep this, simple. So the baby's going to have some ability to throw rocks. So if we come here, we have to decide what our current Powerup. So we need to be able to toggle between those Powerups. Between those Powerups here. So this Boolean is firegrass enabled. This is a little bit misleading at this point because really it should be like, is Powerup enabled? So actually let's go ahead and change it to that, which should then break a couple of other things here. So we'll change this guy to is power up. Okay. Then we need to have the ability to determine which of our guys is the power up to currently show. How might you accomplish that? So we have, right now we have two different kinds of power ups. Later on, you know, if you think about Mario has what, 3 or 4 different kinds of power ups. I know he has the mushroom, he has the fire thing, he has the star. What other kind of power up is there? Is there another one, Mario? Was there more than one kind of mushroom? I know later Mario's had like the flying thing, the feather and stuff like that, but the original Mario, I think, only had those 3. But whatever, there's more than 2. All right, so how would we handle a kind of a generic container that can feed off different kinds of power-ups depending on what we were looking for? Our initial power-up we decided should be the make the baby bigger one, right? But if we had a second power up after we've already done that one, baby's already bigger, then we wanted it to give us a different type of power up. How would we handle that? How would a power up container determine what kind of power up to serve based on the current state of things? Go ahead.
Did you toggle baby's tag?
That's actually a good question. Can you change the tag of something at runtime? You probably can. Well, you definitely can by replacing it with another game object. I wonder if you can directly change it. So let's say possibly. I don't know if that is the... Give me a different approach.
Use the game manager.
Okay. And what would you do with the game manager?
You needed to keep track of which state the baby's currently in, I guess.
Okay.
Or not.
Yep. So if we come in here, we already have a game manager somewhere in here, don't we? Scene manager. So here's our scene manager, and the scene manager, does it have a script?
Mm-hmm.
What's that nothing selected thing? Script cannot be loaded. Oh, it has current compilers, because I think we were just starting to write that, right?
Mm-hmm.
So we go under scene manager. We have our the baby instance for that guy. Well, there isn't actually any error messages with it. Let's just dump that and redrag it in. Oh, that's right. We took off the mono behavior here, right? I think I was asking the question near the end of class, do we actually need to have this script attached to anybody, or can it just be an object that exists? So the second I remove mono behavior, so if we look at like Powerup Container, we see that this guy actually inherits from mono behavior. That's what allows it to be connected to a game object. Okay, this is the guy that gives it the ability to automatically call the update method and fixed update and all that jazz. So the second we come here into our scene manager and say we want this guy to act like a normal C# object, we've now taken away our ability to attach it to a game object. So we'll come back out here. I'll go ahead and I'll get rid of our scene manager object here because we no longer need him in the scene. Instead, we'll just talk to this scene manager directly. And when the baby is first born, let's see, so we can do this inside a baby movement we maybe already did. So inside start for our baby, we set the scene manager's baby instance to this guy. Right, that's the instance of the baby. In actuality, this should be this dot game object. That's the actual game object associated with the baby. But what we did is we wanted access to the script associated with this baby. So we have the baby movement script, not the game object. That's the baby. So that's why it's just this. That's the actual script. All right, so now we can ask the baby for its current state. So we might do something like, there actually is something called an enumerated type in some older languages that would allow us to do something like this, and maybe we'll look at this next week or something. But in general, let's just kind of look at states. So we might say that we might have a public int cur state, and maybe cur state starts off at 0. Okay, and then what we might do here is we might have a, and actually this is going to just be a either int cur state, or we can actually make it, can't make it private, but we don't want to make it public because public would then expose it to, actually that would be okay. In case we want to change the current state of our baby through Unity, I guess we can do that. We can make it public if we wanted to. If you don't want Unity to be able to affect it, then just don't put anything in front of it. I don't think it's going to make a difference in our logic that we're doing right now. Then I want to have a array for holding our power-ups. All right, so we're going to say private, and we have a couple of different kinds of power-ups, right? We have a actually, the current state of the baby is not going to be where it has our power-up. So the baby's going to have its current state. So state 0, state 1. So maybe state 0 is the baby's in its standard position. State 1 means it's bigger. State 2 means it now has fireball access or can throw rocks or whatever it is. All right, so then inside of our power-up container, this is where we're going to hold our collection of power-ups. So we have two different power-ups. We have firegrass and we have rock. So inside here, we'll go ahead and create a private variable. And let's call this, this will be a game object array. We'll call this guy power-ups. And then inside of start, I'll say this dot power-ups is equal to firegrass and rock. I think I had this issue last time. This will be a new game object array of size 2. And then I thought we could then set it equal to firegrass and rock. And it doesn't like us having the things on the same line, unless I'm just writing the syntax kind of funky. So there's my array. See, I shouldn't have had to, unless you have to do it at the very beginning. I should be able to write an array constant. Well, whatever. So we'll say bucket 0 is equal to firegrass. Bucket 1 is equal to rock. So now we've filled up our array with stuff. All right, so what we'll do next time is we'll come back through and we'll ask, which power-up do we show? Well, we'll ask the scene manager's baby state, what state it's currently in, show the power-up that lets the baby go from that state to the next state, and then make sure we increment the state. Make sense? All right. Questions, comments, concerns, bribes? All right, I'll see everybody for the exam on Thursday, and the exam will be in here. Final exam, we're going to try to do the lab. All right.